Well, I'm glad to start considering 48. Seems that I'm getting close to 50 days. I'm happy that you're following with me my journey to get the studying habit or to just get used to studying. Start.
Okay, we're going to tell me, think about it. I'll give you 10 seconds on your own. Think about, don't say it out loud, I ever think of this. Think about what you're going to add to both sides right now. Just think about it. What are you going to add to both sides? That's 4. Not 2. 4. 4, not 16. 4. You're taking this, you're dividing it by 2. Negative 4 over 2, and then you're squaring it. I want you to write that out. Negative 2 squared gives you positive 4. You're adding 4 to both sides. Do you follow? After you do that, you have x squared minus 4x plus 4 equals negative 1/3 plus 4. You're going to somehow add those together. You get a common denominator. That'll be 12 over 3. Add that, you get 11 over 3. That's going to be on the right-hand side. In every single case, what we're trying to do is break off a negative 1 because right now we have a negative inside of a square root. We know that a negative inside of a square root is not possible in the real numbers. So instead of the square root of negative 25, can you tell me what I'm going to write that as? 25 times. Or we could do the negative 1 times 25. Either one. Doesn't really matter. It is commutative after all. That's a true statement, isn't it? Now, what the product rule says, I can split this up as the square root of negative 1 times the square root of 25. And in doing so, I changed that 25 from a negative into a positive, something I can deal with. Well, what we also know is the square root of negative 1, that's something as well. It's something that we've defined over here. It's a definition. It is what it is. So in our problem here, how much is the square root of negative 1, folks? Every time you see that, what are you going to put? And how much is the square root of 25? It's really our free way. We're not going to put I times 5. We're going to put 5i. This value you can represent as 5i. We break off the negative. Square root of negative 1 is I. Square root of anything else, well, we can deal with that as soon as we remove that negative. How about the square root of negative 3? Let's try that. Square root of negative 3. Let's try the same process here. If you have the square root of negative 3, the first thing you might want to do is break that up as negative 1 times 3. Are you noticing how I'm just breaking off that negative? That's all I'm doing. I don't know if you're with me on that. Just breaking off the negative. And then, of course, we do have to separate that. Square root of negative 1 times square root of 3. So far, so good? Same exact steps as before. What's the square root of negative? Negative 1, ladies and gentlemen? Okay, so this is I. What's the square root of 3? Okay, you can't simplify, can't do anything with it. So what do? Just leave it. Can't do anything with that. Square root of 3 is the square root of 3. It's not like square root of 25 where you can actually simplify that. This one, square root of 3, it's already simplified. There's no perfect squares to divide that. It's I root of 3. You're done. Now you're probably wondering, wait a second. Here the I came second, here the I came second, here the I is coming first. What's the deal? Well, just like with variables, just like with variables, when you did this, you probably wouldn't write square root of 3x. You know why? Because a lot of people, a lot of you, end up making your roots a little bit longer, a little bit longer, and a little bit longer, and pretty soon it covers the whole entire problem. Have you noticed some of you doing that? I've noticed it, because I grade your homework. Sometimes it happens, and all of a sudden your x is included in your root, when it's not supposed to be. If we write the x out front, you'll never have a problem with that. Same thing's going to happen here. If you wrote your I in the back, some of you are going to cover that I and forget that it's not actually inside the root. And you're rarely going to have an I inside of a root. Rarely happens. We write the I out front. I root 3 is appropriate. That way we don't confuse the I as being inside the radicand, as part of the radicand. Do you understand why we do that? Here it's not a big deal. 5I, there's no radical to confuse that with. Here we have that. So we're going to write the I in front of our radicals. Let's do one more. I'll give you a few to do on your own. Let's try, oh my, negative square root of negative 50. There's one for you. Okay, first question. First question is this. Does a negative times a negative equal a positive in this case? That would be like multiplying a whole number inside your radical. That would be like saying 3 root 6 equals root 18. Can you do that? That's what you're doing here if you did that. Okay, because that's negative 1, that's negative 50. That'd be like saying that, wouldn't it? You can't do that. So a negative times a negative, well, you're not talking about that in this case. You're talking about negative 1 times the square root of negative 50. Let's stick with the same exact principles that we have over here. We'll have a negative square root, okay, negative square root of, what am I going to break up the 50 as? Okay, I can do that first, but what am I first breaking off? That's true, right? Right? Take your time when you're first going through this. Right now, you're just learning it. You probably never ever saw this before. So don't rush through it. I mean, there's no sense in doing that and getting wrong answers, right? Take your time when you're first learning this stuff. After a while, I promise you, by next week, it's going to come so easy to you, it's not going to be a problem. You'll be able to do a lot of this. Right now, go slow. So the negative stays. Let's split that up. Square root of negative 1 times the square root of 50. Notice how I haven't even dealt with that negative. It's actually going to be outside of our problem the entire time. We're not even going to do anything with it. You're going to see this. This, we just split it up like we've done in the previous problems. So far, so good? Okay. How much is that? That's right. Well, I know this is a negative. How much is that? So the negative is here. This is an I. And the square root of 50. The square root of 50. Can you split up the square root of 50? What is it? 25. So we're going to get 5 root 2. Do you see the 5 root 2? Remember, this is square root of 25 times 2. That's what we're getting the 5 root 2. We have negative I times 5 root 2. Raise your hand if you can get down that far on your own. Yes, no? Are there any questions on that before I can continue? All right. We're going to write this just a little bit better. Remember here how our whole numbers come first? Our radicals come second. That's a negative. So what you can write it as is negative 5i root 2. Negative 5i root 2. Same principles. Whole number would come first, then an I. Weird, huh? kind of cool stuff. You're dealing with things that are impossible in real numbers. That's kind of interesting. You've never been able to do this before in your life, have you? And now we can deal with something. Would you like to try a couple on your own? Let's do the square root of negative 7 and negative square root of negative 18. So put those in, we'll call this I form. Put this in I form. Square root of negative 7, negative 1 times 7. Did you all see that? So we're just splitting off negative 1. That's the only thing we can do because we've defined square root of negative 1 as I. That's the only definition I gave you. That's it. So we'll have the square root of negative 1 times the square root of 7. Square root of 7, I can't simplify that at all. The square root of negative 1 equals how much? Your answer is I root 7. Raise your hand if you got I root 7. Good, all right. Now, next up. Next up. What are we doing here? So this doesn't change? Okay. What's inside of our radical? Times? Good. We're just splitting off the negative 1. We have to split off that negative 1 before we do anything in these problems. Please listen. Anything. Over here, anything. If you have a negative, split it off first before you do anything. Okay? Because those operations we've dealt with don't really apply to the negative roots, right? You have to change those into reals before you deal with this stuff. Okay, so we know that this is going to be negative square root of negative 1 times square root of 18. We have to split up that square root of negative 1. The reason why is because we know everywhere we see the square root of negative 1, we're going to put I. So we have the negative, we have the I, and the square root of 18, I'm thinking that's going to be 3 root. Yeah, that's right, 3 root. So after everything, on your paper you should have a negative. Sure, negative was all the way down. Look at that. Negative didn't even affect our problem. 3, then an I, then a root 2. Which you guys feel comfortable doing at least the I form. All right. I'm expecting now to be able to do this I form every single time. Now, there are some operations we're going to have to do with these imaginary numbers. And the first one we're going to talk about is this multiplication of 2 roots. Remember, we're only dealing with square roots in this section. Okay, so we're dealing with these roots. Now, here's the thing. I want you to watch up on the board, just watch with me for a second. If you try to use the product rule in reverse, what this would say is you'd have the square root of -2 times -7. True. You say, oh, what's a negative times negative? Where you get square root of 14. All right, right. Or, could you change those to I? Notice how this is going to be I root 2, and this is going to be I root 7. Are you following on that? This one is I root 2. Notice how whenever you see a negative inside that root, all it does is bring outside and you have I. And this is, you know, this is going to be negative I root 50. Split down to 50, or break down to 50. This is going to be I root 7. This is going to be negative I root 18. Split up to 18. So whenever you see the negative inside that root, that is simply an I. Are you okay on getting from here to here? You sure? I can show you the steps if you need to, but all you'd be doing is break it up to -1, so remember -1 is I, then we have 2. Times, this will be I root 7. Do you agree? Now I need you to understand what this actually means. This means I times root 2 times I times root 7. Do you follow? Multiplication is called associative because you can move around those little factors and it's still the same thing. For instance, 3 times 2 times 5 is the same thing as 2 times 3 times 5. And reverse those, right? Yes? Yes. Okay. What that means is that this really could be written as I times root 2 times root 7. Do you agree with that? Yep. That's true. It's a true statement. How much is I times I? I squared times root 2 times root 7. Okay, this is the weird part. Watch on the board. Root 2 times root 7, you know for a fact that you can put those things together, right? This is square root, positive numbers inside. You know this is going to be the square root of 14, right? How much is I squared? Yeah, there's 2 things that will be tattooed on your brain. It's going to be painful. Okay, tattooed. The first one is that the square root of -1 equals I. You've been doing fantastic with that. That's got to be memorized. The second one is just as important. How much is I squared? You have to memorize that. That means every time you see this, you're going to write that. Every time you see this, you're going to write that. You with me? Every time. So whenever you see I, how much is I squared? How much is -1 times root? Negative. Whoa! Wait a second. Which one's right? Which one's right? The only thing we failed on this one, the only thing that we succeeded on this one was the product rule. You see, when I defined the product rule, it was not defined for imaginary numbers. It was defined for real numbers. So what this means is that in order to really use all the stuff we've been doing, I hope you're listening here, in order to use all the stuff you just learned in every previous chapter, you have to change it into real parts. This is now a real part. That's now a real part. I mean, a real number in the real system. Okay. Here, this wasn't. I didn't change us to reals yet. This operation is not defined for imaginary numbers for the product rule. You can't just multiply them like you would a real. They're not reals. It's not defined. So this part failed us. That's actually not true. You can't do it. You have to change to I form first and then do the math. So is it root 14? or negative root, it's negative root 14. We know that this is all true. We know that's all true. This is the true part. Did you see the point? You got to change the I form first. And this is absolutely crucial for you to identify every single time you see it. You cannot mess that up. Let's try a few more together. We'll do 3 more together. I'll give you a couple on your own. Then we'll finally get into complex numbers. Look at what those things. That'll be the fun part. That's good. I think you will really like the complex. I promise you'll really like the complex numbers. I just like them. Some of you might not, but I like them. I'll like them enough for all of us. All right? Okay. Good. We're good. Okay, first thing is to multiply these and get positive 25, or first thing is to change the I form. Which one? Every time you see a negative square root, you are going to change the I form first. That's what I've been saying this whole time. So the square, can you identify how much the square root of negative 1 is? How much is this over here? So I know that's an I. Okay, very good. Now the square root of negative 25, how much is the square root of negative 25? This is going to give you the I. This is going to give you the 5. You should get 5i out of that. Not the square root of 5, but 5i. You see why? We actually done this problem before. Look back in your notes. We did the square root of negative 25. This is 5i. 5i times I. How much is 5i times I? 5i squared. Okay, so 5i squared. How much is I squared, everybody? 1. I could actually write it 5 times negative 1 if you'd like. I squared is negative 1. That's going to be negative 5. This answer is negative 5. We were going to write negative 5 in there.
So it's just converting imaginary numbers into real.
And we're converting negative square roots into imaginary numbers. They are representing the same thing. We're just writing it a little different. This still is a square root, right? And that still is a square root. This is the square root of negative 1. This is the square root of negative 1. All those principles of roots that we've dealt with work. They are roots. You're just writing as i's. First thing, tell me. Form. Square root of 27 times, can you tell me how much this is in I form? What would you write that as? A square root of negative 3. Good, the negative gives you the I. The root 3 stays the same as root 3, you get I root 3. We'd actually done this one in class as well. So far, so good? Okay. What now?
27 to 93.
You could. There's actually 2 ways to do this. First way. To simplify this one, multiply root 3 times root 3 and get 3. Second way, multiply these 2 roots. Notice how they're both real roots now and you have a multiplication here, right? What's root 27 times root 3? That's something I can deal with. That's root 81. How much is square root of 81? Get 9 out of this. This is going to be 9i. Either way you do it. You could do 3 root 3 times I root 3. You know, a root times itself gives you the radicand. Do you remember that? This is 3 times, this gives you 3 times I, or 9I. Or you could do square root of 81 times I, 9I. Either way, you get 9I out of that. Do you see both ways on that? Both ways there. Square root of -8 over 2. And you know the first thing you're going to do is change it to I form. Right now, I want you to change the numerator into I form for me. What is that as I form? You definitely need I, right? So you know that's going to be I root 8. Do y'all get I root 8 at some point? Now, can you simplify the root 8? Don't forget that you can simplify these. Now they're just normal square roots after you take the I out. So if we simplify the square root of 8, this is going to be 4 times 2. That's 2I root 2. How many people got 2I root 2? Left side? Yes, okay. So remember, this is square root of 4 times 2. You have the I. This gives you a 2. 2I root 2 over root 2. What happens with this problem?
Cancel out the root 2 and we'll get to it.
It's all being multiplied, right? So any factors you have that are being multiplied, what's up? You've got a root 2 and root 2. Gone. That's awesome. What if you didn't do that? What if you had I root 8 over root 2? How'd you do it? Well, you now have a square root over square root, don't you? You could write this as I root 8 over 2. Now you can combine them. Now you can't, because you don't have the negative in there. You have I root 4, or you'd have 2I. In either case, you're going to get 2I. So are there multiple ways to do these problems? Absolutely. Both of them are valid. Neither one is better than the other. Okay, you can do it either way that you want to. I really don't care, as long as you're changing the I form first. How many will feel okay about changing the I form first? Good. I'm going to have you do, let's see, maybe 2 on your own. Then I'll talk about complex numbers. change to I form first. Oh my, don't multiply these together and get like a square root of positive 30. That'd be a big no-no. That doesn't work for those imaginary numbers. All because I squared can give you -1. So change it to I form first, then look what happens. Looks like we're about done. I'll give you a few more seconds here to wrap up the number 2 if you haven't done that. Okay, so square root of -5 times square root of -6, we can't multiply those the way they are. The first thing you do whenever you see the square root of a negative number, change it to I form. That way you're safe in every case. You're going to notice a couple things, especially on this problem. If you were to put those together as one root, which you technically shouldn't do, you would get the square root of -9. That's going to give you 3i. That's probably going to be your answer at the very end of this thing anyway. Did you get that as well? Okay, so sometimes it looks like it can work. Just it does actually here, because that you only have that one negative, and you're not going to cross out that negative. You're not going to eliminate the I. Here you can. So in both cases, though, it is appropriate to change this to an I first. I root 5 times I root 6. Are you okay that I'm going directly here to my I's? Is that all right with you? Yeah. Okay. It's pretty quick to catch on to that, isn't it? Not too bad. Then we notice that we have I times and I times. So we've got this I squared. Notice where we get I squared from. Root 30. Did you make it down to I squared root 30? We reassociate the i's. I times I gives you I squared. Root 5 times root 6. We can do that now because they're now real parts. We get how much? That's -1. -1 times root 30 is negative root 30. That's it. That's what you do. Cool. Next up, we are going to change I form first. That's what you really should do every. Single time you see this. So we get here from the square root of -27. I root 27. Over 3. You got two choices. You can choose to simplify the square root of 27, or you can put those roots together. Either way you want to do that, it doesn't really matter. You can do 3 root 3 or 3i root 3 over root 3 and cross out the root 3's. Or, if you prefer, you can combine these things, get the square root of 9, because 27 divided by 3 gives you 9. In either case, you're going to get 3i out of this problem. Are you with me? I'll show you this one, because for some reason, I feel like doing this today. That's just who I am this week. Not this morning. Not this weekend. I'm DJing and singing this weekend. I'll be on microphone all weekend. Okay, how many will feel okay changing to I form and simplifying some of these roots? Yes, no? Yeah? Oh, I almost feel job there. Complex numbers. We've been dealing with imaginary numbers. All these i's are called imaginary numbers. They're just a little part of a different group of numbers, called the complex numbers. See, here's the thing. What we're going to do now is pair up a real number with an imaginary number, and that creates the set of complex numbers. Now, you probably have no idea how big the set of complex numbers is. We'll talk about it in just a second. A complex number is of this form. A plus bi. A plus bi. A is called the real part. It'll be a real number, like 3. -2, the square root of 5. Something without an I in it. So A is called our real part. BI, well, the I is imaginary. So the BI, that's our imaginary part. So we're going to have something like positive plus or minus here, like 3i, or -4i, or the square root of 7i, something like that, or I root 7 is how we will write it. This is the imaginary part. If we pair them up like this, we get a complex number. Now, I've got to tell you that you probably think the real numbers are a huge set of numbers, right? I hope you do, because they are. They're infinite. I mean, every number you've ever thought of before this section was a real number, right? 1/4, real number. Square root of 8, real number. 34, real number. All the negatives, real number. Pi is a real number. Every terminating, non-terminating, repeating, non-repeating decimal is a real number. Everything. Now, what we're doing is we're pairing up a real part, a real number, with an imaginary number. Here's what this means. Try to grasp this. For every real number you can imagine, everything, I could add on an infinite number of imaginary parts. Give me a real number. Any real number you can think of.
7.
7, great. I can have 7 plus 2i, 7 plus 3i, 7 minus 4i, 7 minus the square root of 2i, 7 minus 8i, 7 minus a whole another set of numbers that's infinite. Anything you can think of. So for every real number, you have another infinite set of imaginary numbers you can pair with. Do you follow how big that is? Now give me another number, make it 2. You can do the same thing. They're massive. In fact, every a real part, a real number, with an imaginary number. Here's what this means. Try to grasp this. For every real number you can imagine, everything, I could add on an infinite number of imaginary parts. Give me a real number. Any real number you can think of.
7.
7, great. I can have 7 plus 2i, 7 plus 3i, 7 minus 4i, 7 minus the square root of 2i, 7 minus 8i, 7 minus a whole another set of numbers that's infinite. Anything you can think of. So for every real number, you have another infinite set of imaginary numbers you can pair with it. Do you follow how big that is? Now give me another number, make it 2. You can do the same thing. They're massive. In fact, every real number you've thought of is encompassed in imaginary, is encompassed in complex numbers. Complex numbers are a much larger set of numbers. Here's how I can show you this. All numbers are complex. If you take all numbers are automatically complex numbers. Let's take that number that someone said, 7. If you give me the number 7, now that's clearly a real number, right? Right?
Yes.
Now check it out. Can I write it of this form? Absolutely. My real part is 7. My complex part is 0 i's. I don't have any i's. That's automatically complex. Kind of neat, right? Do you see how that's possible? 7 plus 0i. It's complex. Doesn't say anything about what b has to be. This is automatically a complex number. Or if you give me an imaginary number, let's say, what's on the board? 3i. If I take 3i, what's my, okay, watch carefully. Listen a bit. Were you okay that the real part here was 7 and the imaginary part, there wasn't one, so I put 0i? Be careful here. What's my real part? 0. It's not 3. This is part of the imaginary part. Are you with me? So the real part would be 0 plus imaginary part is 3i. Every imaginary number is automatically a complex number. That means that every number you've ever had in your life, every number that exists, is automatically, without a doubt, a complex number. It's the biggest set of numbers we have. So far, so good?
So, by all imaginary numbers, it's not that they're fake numbers, they're just not
Real.
able to be lined up.
No, it's logical. Very logical. It's just they're not real. They're not in the real number system. So we can't call them real numbers anymore.
Because real is a group, not like having a reality.
Right. Real is a group of numbers. Imaginary is another group of numbers. Put them together, you get complex numbers. Yeah. Let's talk about how to add and subtract these. Now, you probably might think, oh my goodness, these are complex numbers. Adding and subtracting them is going to be complex. No, not complex. I'll give you an example, for instance. Let's do 5 plus 2i plus 4 minus 3i. The only reason these parentheses are even there, ladies and gentlemen, is to show you that I have one complex number plus another complex number. Can you guys see the complex numbers? I know it's weird to you because it's new. That's one number. That's one number. You with me? Tell me what the real part is here. What's the imaginary part here? Negative 3i goes with the sign. What's the imaginary part here? Real part here. Check it out. Do you remember how, you remember how to combine like terms? How you combine like terms is you get rid of parentheses first, and then you combine like terms. Notice that we do have addition. I need to be very clear on this with you. Would you distribute this problem? Is it multiplication? Am I going to go 5 times 4? Am I going to do that? No, don't do that. I'm going to give you a problem just like this on the test. It is the easiest 10 points you're ever going to get, unless you distribute. You get 0 points. And you know what addition means. Addition means, well, if there's nothing to distribute out front, I get to just drop the parentheses. How about this? Do the signs change inside of this one? So what this means is just plus 4 minus 3i. True? Do you have some like parts? Do you have real parts? Do you have imaginary parts? Add them. Combine them. Combine them like you would like terms. I know that 5 and 4, those are like parts. How much does that make? I know that positive 2i and minus 3i, those are like parts. How much is positive 2i minus 3i? Minus I. Can you combine these things? No. This is very much like terms. I know that I is not a variable. In fact, how much is I? You should all know this. No. Yes, square root of -1. So what you have here is a number minus a square root, right? What you have here is a square root and a square root. They're like roots, as a matter of fact. This would be 2 root -1. This would be 3 root -1. That's why you cut. They're not variables. You can't put anything in for I, but you can combine them as if they kind of were, because we did that with our roots as well. That's your answer. Kind of nice. Kind of nice. Let's try some subtraction. I'll give you on your own. Probably call it a day after that. 6i minus 2 minus I. All right, well, let's talk about this for a bit. Firstly, recognize we do have two complex numbers. Everything's a complex number. What's the real part here? 0. The real part's not 6. This is associated with the I. The real part 0. How much is the imaginary part? Good. What's the real part here? Imaginary part. I or negative I? Negative I goes with the sign. Can you tell me what's going to happen here? Just like combining terms. You get the 6i, sure. But what are you going to get when I distribute my negative?
Negative 2 plus I.
Wait. Why plus I? Good. If you forget to distribute that, are you going to get the right answer? No. So this, when I go, that's going to be a plus I. Now, I know a lot of you, if you like to do this, you like to see these like parts here. You like to combine them. How much is that going to be? Is it going to be 6i squared, or 7i, or 7i squared? Squared?
7i. Right, so.
Are you multiplying or adding?
Yeah.
Just like terms. 6x plus 1x will give you 7x. True?
Yes.
6i, 1i gives you 7i. Now, we do have to write these in appropriate order. So, is it going to be 7i first or last?
Last.
What comes first then?
Real number.
So, identify your real parts first. We have negative 2. This is 6i plus 1i, that's plus 7i. Negative 2 plus 7i. Okay, last one we'll do together, then I'll give you 3 to do on your own. We'll go over them very briefly, and then we'll be done for the day. Oh, what do you do here?
Distribute the negative to the second.
Notice our two complex numbers. We have negative 2 is our real part, negative 4i is our imaginary. Imaginary. Negative 3 is our real part, positive 1i is our imaginary part. Are the signs on your first complex number going to change, ladies and gentlemen? Someone on the right side of the room for me, can you tell me what I should write here, please? Good, plus 3, not 2 signs. You know, a negative and negative is positive. And then what? Good. Follow me? Make sure you distribute those correctly. Make sure you get the appropriate signs there. Because now all you got to do is combine some like parts. We do our real parts first. What's our real part going to be, everyone? Okay, and then I have a minus 4i and a minus I. You're basically combining like parts here. You're going to get what? Can't go any further than that. That's it. Okay, try a couple on your own. Let's do 3 minus 5i plus negative 4 plus I. And that one. Were you guys okay with this example? Do you know one like that, or are you alright with that one? Very, very similar to these problems. Go ahead and do those. I'll give you about 30 seconds and we'll wrap it up. any signs change in the first expression? Do I need to distribute and FOIL this? So 3 minus 5i plus, okay, negative 4. What I could do here is just write minus 4. You see that? I could just write minus 4 and then plus I. So far so good? This is going to give you negative 1 minus 4i. Raise your hand if you got that. Good. Next up, we do have to distribute the negative, not FOIL, but distribute the negative. You'll get negative 5 minus 2i. You'll get plus 8 plus 4i. If you get plus 8 and plus 4i, follow that sign. You gotta have that. Our real parts give us 3. Our imaginary parts give us minus 2i. And now we can add, subtract. I'm sorry, plus. Thank you. Plus 2i. We can add and subtract those complex numbers. Do you feel okay about what we talked about today?
Yes, sure.
Next time on Monday, we'll talk about how to multiply and divide them. They'll go very fast. Then we'll start chapter 11 on Monday. Well, good morning. If you remember from last time, what we're doing here is we're doing a few things with the square root of negative numbers. We realized from last time that the square root of negative isn't a real number, but it is an imaginary number. It's a different class of numbers. And when we pair that together with a real number, we get something called a complex number. The whole idea is, can you put these roots into I form, and then can you do some operations with them? We've practiced I form a lot. We've also done the addition subtraction. We're going to get to multiplication division in just a little while. First, let's practice doing this problem. What I'd like you to do on this is make sure you put that I form before you do anything with it. So right now, take about 5 seconds. It's not hard. It doesn't take a long time. Put this in I form for me. So I form means you're getting rid of a square root of a negative number somehow. So let's take a look at it. Do we need to do anything with the 4? No. Okay, so I know this is just going to be 4, and this minus is still going to be a minus. All I'm asking you to do is convert that root somehow. Now, what is the square root of negative 25? Is it a real number or an imaginary number?
Imaginary.
Definitely, because it has that negative inside that root. What does that negative create? I. Somehow it's going to have an I. And if you remember from last time, I'll show this to you one time because we've done this quite a bit. You can refresh your memory on that video. But what we would do is with the square root of negative 25, we break that up into negative 1 times 25. We split up the root. And we would have I times 5. We determined that, and we defined that the square root of negative 1 is actually I. That's what we're using this as. So instead of I5, we'll have 5I, and that is called I form. Do you remember that from last time, ladies and gentlemen? Okay, so here, instead of 4 minus square root of negative 25, we're going to have 4 minus what? 5. Minus the negative 3 I can't do anything with. The plus I can't do anything with, but that square root of negative 4, how much is that? Good, we take the square root of 4, square root of negative, that's negative 1. That's your I, so we get 2I. Notice how I haven't really done any other math besides changing that into I form. That's the whole idea. Make sure you get I form first, then go ahead and look at the problem that you have. So I form, very important, we're going to do that first. Next up, oh, let's look at what we're actually doing. Are we adding, subtracting, multiplying, or dividing? Subtracting. And in fact, we have complex numbers now. Do you guys see the complex numbers? What's the real part of this complex number right here?
Negative 3.
Right side of the room, what's the imaginary part of this Complex number over here. So it goes with the sign. Okay, good. Now, if we're subtracting, do I need to FOIL this? Do I need to distribute that? No, really, all I need to do is make sure this negative switches these signs, because we're subtracting them. Just like combining like terms, we remember how to get those parentheses out of there. So we'll have 4 minus 5i. We'll have, what's next? Plus or minus? Okay. And then what? Minus 2. And after that, essentially what we're doing is combining like parts. Very similar to combining like terms. Now, remember that, is I a variable? Is I a variable?
No.
How much is I? No, I is not -1. Square root of -1. Yeah, I can't have you say I is -1, because I squared is -1. You can't have the same thing for both of them. So I is not -1, but it's the square root of -1. So what we're really doing here is we're combining a couple of like roots. These are the square root of -1. That's why we combine them just like a like term. And then our numbers are always like terms. So we'll combine our 4 and our 3, that'll give us 7. We'll combine minus 5i, minus 2i, and get minus 7i. And that's as far as we can go. The real part's 7, the imaginary part's -7i. We're done. How many will feel okay with the adding and subtracting? Good. Now, for the rest of our time in this section, we're going to talk about how to multiply and how to divide. We'll talk about multiplication first. You know, there's really only one thing that you need to know in order to multiply these complex numbers. Really, that's it. Just this right here. You need to know and have down in your head at all times how much I squared is equal to. How much is I squared equal to? If you remember that, and if you remember that every single time you see I squared, you're going to put what? If you remember that, then you can find multiplication. You see, here's what we're going to do. When we multiply, oh, by the way, if this is true, should you ever have just this right here, you need to know and have down in your head at all times how much I squared is equal to. How much is I squared equal to? If you remember that, and if you remember that every single time you see I squared, you're going to put what? If you remember that, then you can find multiplication. You see, here's what we're going to do. When we multiply, oh, by the way, if this is true, should you ever have any I to greater than the first power? Should you ever have an I cubed or an I fourth or an I? No, because if you know this, you can always simplify it. And we'll talk about that in just a bit. But we're going to be multiplying, and it's going to look very, just this right here. But it's a square root of -1. So what we're really doing here is we're combining a couple of like roots. These are the square root of -1. That's why we can combine them just like a like term. And then our numbers are always like terms. So we'll combine our 4 and our 3, that'll give us 7. We'll combine minus 5i, minus 2i, and get minus 7i. That's as far as we can go. The real part's 7, the imaginary part's -7i. We're done. How many will feel okay with the adding and subtracting? Good. Now, for the rest of our time in this section, we're going to talk about how to multiply and how to divide. We'll talk about multiplication first. You know, there's really only one thing that you need to know in order to multiply these complex numbers. Really, that's it. Just this right here. You need to know and have down in your head at all times how much I squared is equal to. How much is I squared equal to? If you remember that, and if you remember that every single time you see I squared, you're going to put what? If you remember that, then you can find multiplication. You see, here's what we're going to do. When we multiply, oh, by the way, if this is true, should you ever have any I to greater than the first power? Should you ever have an I cubed or an I fourth or an I? No, because if you know this, you can always simplify it. And we'll talk about that in just a bit. But we're going to be multiplying, and it's going to look very, very similar to some multiplication that you've seen before. So let's say I gave you negative 5i times 3i. Well, hey, if you can do this problem, which you've done before many times, right? You can do this problem because it's the same exact idea. You're multiplying two things. You're multiplying negative 5i times 3i. You're going to be multiplying the numbers together. You're going to be multiplying the i's together, just like you multiply the numbers together here and the x's together. Now, well, this isn't a variable. It is a root. And we know that those roots get multiplied just like any other numbers do. What would you get out of this problem here? Wait, x or x squared? Where's x squared coming from? Okay, so you need to know that combining i's by addition or subtraction is different than combining i's by multiplication, right? Just like combining roots with addition was different than combining roots with multiplication. We realized that. That was a big part for us because some people were still putting roots where you didn't need them or not having roots where you did need them. So on this case, we're doing an I and an I, yet it's still only giving us an I because we're adding and subtracting. Here we're going to do an I and an I, but it's not just going to give us an I, it's going to give us x squared. Oh, sorry, not x squared. No, we got that. We're going to get an I squared because we're multiplying just like we are right here. So where we got negative 15x squared, we'll get negative 15 I squared. Do you see where the I squared is coming from? Yeah. Do you see why we have it here, but why we don't have it here? Do you? Sure, we're combining like terms here. We're multiplying over there. Different story. Addition, subtraction, multiplication. We're going to have to be okay with it so far. Okay, good. Now, we just finished talking about something. Just finished. Should you ever have an I squared on your paper? No. Let me tell you something. If you finish with an I squared on your paper, you've either done something wrong or you're not done. All right? So if you finish the problem with I squared, you can't have that. Why? How much is I squared? So instead of having negative 15I squared, I know it's negative 15 times negative 1. Can I complete this problem? It's just negative 15 times negative 1. So interestingly, we don't even get an I out of that. Look at that. We've got a negative 5I, that's a 3I, we get positive 15. It's weird, right? Things happen with roots. These are roots. These are roots here. And what's happening is you're multiplying a root times itself. Notice that? A square root times itself. What's a square root times itself do? Get rid of the square root. That's why we do this. That's why this happens. We're going to use this idea in division in just a little while. Do you feel okay with our example here while we get positive 15 out of that? Yes or no? Yes. You sure? If not, ask some questions. We get time. Get another time. All right. Well, let's continue. Let's do a few more. But as long as you do get this idea that we're not supposed to have an I squared at the end of a problem, that's actually negative 1. And we're multiplying very similar to like we multiplied before in this class, then you're going to be okay. Let's build this up just a little bit. Try a few more examples, and if you have questions, please let me know. All right. What do you say, folks? What do you think? What are we going to do on that problem? Just like we would have done if these were variables. Now, these are not variables, they are roots. But just like you do with variables, you're going to distribute those. We've got a parentheses, we've got a term outside, a factor outside being multiplied. We know we can get rid of those parentheses by multiplication. So can you tell me, let's go left side of the room. Left side of the room, what's the first thing I'm going to get out here, please? Good. Perfect. Negative 18.9, do you see where that's coming from? Just like as if that new variable. And we're also going to multiply this in here. Am I going to get plus or minus with this? Yeah, don't forget how to distribute. We all know how to do that. Plus, oh, let's see. What do we got here? Plus what? Firstly, do you see where the plus is coming from? Okay. So plus, we're going to have 6. And are we going to have I or I squared? What do you think? Are you done?
No.
Can you combine these?
No.
Can you combine? Are they like radicals?
No.
This is actually a square of a radical. That's going to go away. That's why we can't have an I squared. You're going to simplify that. How much is I squared, folks? Okay. Now, go slow down these things. I know that they are going to be easy for you. They're going to get easy. Are they always easy for you? They're going to get easier for you because you're going to get used to it. However, when you speed through them and you try to think of all those negatives in your head, sometimes you get a little lost, right? So I don't want you to go directly from here to your final answer, because this negative times a negative, then you're going to have another negative in there that can really get wrapped up in your head and make some mistakes with that. So show me the steps on that. It doesn't take a long time, right? Maybe 2 steps, maybe 2 or 3 if you have a really rough problem. But show the work. Make sure that you really think about what's going on. Are you with me? Yeah, otherwise, something bad's going to happen. So we distribute, we get negative 18i, we get positive, negative, positive 6i squared. Can I change this I? No, that's the square root of negative 1. I can't change that. Can I change this I squared?
Yes.
So do that. I know I have negative 18i plus 6. And write this out. Write it out before you change anything about it. Leave the plus, leave the 6. Just change that part. How much is this part right there? Good. Now go ahead and do the math. Now that you've translated the I squared to the negative 1, now multiply, and that's where we can change our signs here. Of course, we're going to leave it negative 18i. That's not going to change. But am I going to get a plus or a minus 6 after I do that math? Would you guys feel comfortable getting down to this far? Good deal. Now, there's one problem with this. This is a complex number. However, it's written a little bit backwards. You guys see what I'm talking about? We typically like to write the real part first. So if we do that, we're just going to move these pieces around with their signs. We'll have negative 6 minus 18i. That's the appropriate way to write a complex number. Let's go ahead. We'll do a few more examples. I'll give you a couple to do on your own. Move on to some division. Look how we do that. You know what's nice about these problems is even though we're working with like I squared and we're changing those things, at least they look familiar, don't they? Look like things we've done since literally the first day of class. We've done things like this. How are you going to do this wrong? You're going to distribute. In this case, do we FOIL?
Yeah.
So notice how this problem is a different problem than if we have a plus or a minus between them. If I have a plus or a minus between it, am I going to distribute it? No, definitely not. No, because then I'd be adding or subtracting two complex numbers. But here, since that is multiplication, that does clue me into let's distribute it. Let's go ahead and let's do that together. If I distribute everybody, what's the first thing I'm going to get? And then what am I going to get?
Plus 3i.
Great, I like the plus 3i. I'll do that. After that, I've done the 3 times 6 and the I. What's next, folks? Minus 24 I. I swear, where's the?
Oh, sorry.
Okay. And then last thing we're going to do, this one, we're going to get how much? That's the I squared. You guys see where the I squared is coming from? You can't afford to have an I squared where you don't need one. You can't afford to forget an I squared where you do need one, because that's going to change your problem. You see, look at this. Look at the board with me. I know you're working on your own because you guys get this. That's great. I'll give you some in a bit. But if you do this, notice how now this all becomes like radicals. Do you see it? But if you do this, these two are ultimately going to become like terms. Do you see it? So that's the difference. You'd be adding or combining the wrong thing.
So there's never three different types inside a complex.
No, inside a complex number, you have two choices. You have something with I or you have a number. That's what I'm saying here. You can't ever end with an I squared. There's no such thing as having an I squared to end your problem. You can always simplify it. Always. So you'll either have numbers or I's. Never have an I squared, I cubed, I to the fourth, never. It doesn't happen. Are you still with me? Now, before we go and combine anything, we're going to change any I squares that we see. Of course, I have the 18. That's good to go. And I've got the plus 3i. There's nothing I can do with that. The minus 24i, again, there's nothing there. Well, there's something there, but I can't change it. And then over here, though, that I squared, that's going to be something I can change. I know I have a minus 4. I'm not going to change it yet. I really want to think about what I squared does. I want you to realize that. This isn't just changing signs. You're changing I squared to a -1. Ultimately, that is going to change your signs, but I want you to show that work. That clues me in that you understand what I squared actually means. Still okay?
Yep.
Okay. So the 18, no problem. Plus 3i, okay. Minus 24i. Am I going to have minus 4 or plus 4 after that? Sure. That's what that I squared is doing. What next? Let's do it. We should have only numbers and I's. See, a couple numbers, 8 is 22. We'll write our real part first. I've got a 3i, a minus 24i. That's going to give me how much? I? Yeah. That's it. We have a real part. Imaginary part, that's our complex number. Hey, tell me something. What are you going to do with this problem when I give you one like that on a test? If I give you one like that on a test? So you're not just going to square this one and square that one?
No.
We can't just do 1 plus 4i squared or minus 4i squared?
No.
Now, unfortunately, if we did that, we'd be missing some middle terms here. So when we get something squared, of course, when we multiply, and we did this with distribution when we first started that, we are going to write it out. You say, oh yeah, I know that this means 1 minus 2i times 1 minus 2i. And from there, sure, we can FOIL it. Why don't you go ahead and FOIL this out for me and see what you get? All right, so if you distribute, if we distribute, we're going to get the 1 times 1. I know that gives me 1. Then I'm going to get the 1 times minus 2i. That's going to be minus 2i. But then I have that same thing again. I have minus 2i or negative 2i, which you can consider it as, times 1. That's another minus 2i. But lastly, I have minus 2i times minus 2i, or negative 2i times negative 2i. That negative, negative, that's going to create a positive for us. So plus, and I will get 4i squared. How many will have that on the paper? Good, that's just our distribution, right? I mean, we need to at least know that part of it. Now, the important part for us, the extension part of this is really old stuff, right? I mean, we really need to know this in order to even be in the class. After this, the part we're extending the concept is just I squared. That's really it. Can you do something with the I squared? So here it's the 1 minus 2i plus 4. Just change the I squared to that negative 1. We know that's a definition for us. Every time we say I squared, it means negative 1. What that does is simply change that sign, really. 1 minus 2i, and then minus 4. Lastly, if we put our like parts together, we've got 1 minus 4, that's making a negative 3. We've got a minus 2i and a minus 2i. How much does that give us? Are you done? Negative 3 minus 4i. Do you feel okay with doing this so far? All right, let's look at the next problem. Do you remember the relationship between this type of complex number or this type of complex number? Do you remember this relationship? We talked about it before. However, I was using roots at that time. I was using those roots. Now, in fact, do we actually have any roots up here? Yep. How much is I? It's the what now? The square root. So that's a square root, right? And that is also a square root. Do you remember the relationship between this and this? Yes, I know. What was that called? I know the middle terms probably are going to cancel out here, right? Because I have different signs here and I have the same. Some people said difference of squares. That's what I would get at the very end of this problem. But say it again. Conjugate. Remember that? Conjugate. It's conjugate. It was a conjugate that we had. We have the same exact terms. It's just the sign in the middle is different. What that did with our roots was basically eliminate the square roots out of our problem. Because we knew this. A number times a number is going to give us a number. We knew a root times a root would eliminate the root, give us the radicand. That was for the square roots. But those middle terms will be off by a sign. That allows you to cancel them out, cross those things out, because when you add them together, they make that 0. Do you remember doing that? Now let's see if it works here. It should, because we still have square roots. We're just writing them as i's. Let's see if it works. So distributing, can you all tell me what's the first thing I'm going to get? 36. Okay, keep going. What's the next thing I'm going to get? Minus 30i. Yeah, that's right. Minus 30. Do you see where we're getting the minus from? Plus 30i. Great, okay. Great. Positive times a negative. That's a negative. All right. Minus 25i. Don't forget that I squared. That's going to change your problem, right? Don't forget that I squared. Do you see anything interesting that's going to happen? Yeah, they do. I've got a minus 30i. I've got a plus 30i. That's what happened with those conjugates before. That's what's going to happen with these conjugates now. We do have 36 minus, from our minus 25i squared, I can write that minus 25, I squared is negative 1. See where we're getting this minus from and the negative 1 from. Are we going to add or subtract 25 to 36? Okay, this really means that. And that really means, wow, that's weird. Look at that. We started with this. We ended with a whole number. Isn't that kind of crazy? We eliminate the roots. I's are gone because I squared is negative 1. If you don't remember that, you're going to end up at this part, right? You're going to have some sort of negative I squared up there. It's going to look weird. It's not going to be the number. You would still think in your head you have a root with. That, there you go. Would you raise your hand if you're okay with multiplication? Okay, I'm going to give you a couple problems on your own. They go very quickly, but I do want you to show your work on this. Don't just do them in your head. That's where the mistakes with those negatives happen.
I have a question. If you were to write that as a complex number, you would have plus 0i, right?
Yeah. Yep, and that's because right here, when you have negative 30i and positive 30i, how many i's do you end up with? 0 i's.
Oh my God.
Okay, try these out. Let's see how you're doing. So we know we're multiplying. Wherever we get an I times an I, we're getting I squared, but then we know we can't leave this with an I squared. The I squared becomes -1. Distribute where you have to. Remember, this is different than adding and subtracting complex numbers. So on your test, I'm going to give you adding and subtracting and multiplying and dividing complex numbers. None of the math is too difficult. You just have to know what to do, what you can do, what you can't. only two examples I can give you. Do you feel okay with them? Raise your hand if you do. If you're not raising your hand, assume that you don't. Oh, you do. Okay, we got it. Try 2 on your own. We'll talk about one more thing, the powers of I, and then move on. Questions?
Before you read that.
What now?
On the bottom one, how it says like 3 over 13 plus 11.
Yeah.
Is there any way that we could still like simplify that and make it like where it's 8 over 13? Where you are?
What now?
Or, I mean, I'm sorry, 13 over 13. Maybe I.
Like if you add those?
No, yeah, right there.
Okay.
Yeah.
Do what now?
We're gonna add, like 14 over 11.
No, okay, I see what you're saying. No, remember that this is a number, and this is a number attached to I. It is really similar to having something like this. Can you add those? No. This has the I with it. Now I know I'm writing the I after the fraction, but notice it is still multiplied. The only reason why we're allowed to do this is because this is the same as this. True? Which is the same as that's equal to I. That's why we're able to do that. This fraction is still this fraction. Okay, you're not allowed to add those together. That's why I can do the I but back into that. Same reason. Oh, did that answer your question? So, this is gone now. Okay, try 2 on your own, and then we'll talk about powers of I briefly and be done for our day. Do that one for me. And this one. So to divide those complex numbers, we multiply both the numerator and the denominator by the conjugate of the denominator. The reason why this works again is because that I really is a square root. It's a square root of -1, and we knew that the whole conjugate idea is going to eliminate those square roots on the denominator of our fraction. That's why it works. It's eliminating those i's because they're square roots. We just can't lose the fact that we're going to have some I squareds. We can't lose the fact that those things are -1, and that's going to change some of the signs inside of our problem. Hey, what's the conjugate we should be working with up here? Yeah, don't let it change into a 1, right? That would be a bad thing. Hopefully you multiply by 3 minus I over 3 minus I. And then you're going to, did you get that on your numerator? 12 minus 4i minus 3i plus I squared? You get the I squared? You get the 9 minus 3i plus 3i minus I squared? Hey, do these I squared simplify? Can you cross those out? No, yeah, you get some subtraction in there and some addition. You can't do that. Next thing we're going to do is change the I squareds we have into -1s. So we'll have the 12 minus 4i minus 3i, and then this is going to be plus, this is doing for us minus 7i. 9 plus 1 gives us 10. Minus 3i plus 3i, that's what we wanted to have happen. Those i's are gone. We get this number. How many we got that for? I. This is I. 1 times I is I. What just happened?
I have no idea.
What just happened? It's cyclical. It's going to go back. That's going to give us negative 6i over positive 9, and if we simplify that, we get negative 2/3 I. Would you actually feel okay with multiplying and dividing these complex numbers? Now, the last thing we're going to talk about in the last minute that we have, we're going to talk about powers of I. I want you to notice something. Of course, I to the first power is I. How much is I to the second power? Okay, I'm glad one person knows that. How much is I to the third power? And I to the fourth power? And I to the fifth power? Here's what we're going to look at. Check it out. I to the third power, do you believe me? I can write that as I squared times I. How much is I squared? This is really -1 times I. -1 times I is negative I. You follow? Check out I to the fourth. I to the fourth is I squared times I squared. Is it not? How much is I squared, folks? No, I squared is not I. I squared is negative 1. This is negative 1 times negative. How much is negative 1 times negative 1? Weird. I is I. I squared is negative 1. I to the cubed is negative I. I to the fourth is 1. How much is I to the fifth? I want you to check this out, okay? This is I to the fourth times I. Do you follow that? I to the fourth was 1. I is I. This is I. 1 times I is I. What just happened?
I have no idea.
What just happened? It's cyclical. It's going to go back. This is a little bit of number theory I'm teaching right here. Guess how much I to the sixth is going to be?
I to the fifth.
No, negative 1.
Times I.
How much is I to the seventh? How much is I to the eighth? How much is I to the ninth? 10, 11, 12, 13, 14, 15, 16, 17, 18. This is what you're going to do with your eyes. And if you want to figure out how much I to the, just listen. If you want to figure out how much I to the 50th power is, you want to do this 50 times? No. Divide 50 by 4 for me right now. And find the remainder. Do it. Did you get 2? This remainder says I to the 50th is equal to I squared. The remainder tells you where you're at. So you divide your power by 4, because you have 4 in your cycle. The remainder says I'm equal to I to that power. So you just look back at your table. I know I squared is negative 1. Therefore, I to the 50th is equal to negative 1. Take your power. Divide by 4, find the remainder. Hey, by the way, if the remainder is 0, I to the 12th, divide that by 4. It goes in 3 times, you get a remainder of 0, true?
Yeah.
How much is I to the 0 power? How much is anything to the 0 power? No, it's 1.
Trick question.
No, it's not your question. Anything to 0 power is 1. No matter what. Divide the power by 4, take your remainder, it's I to that power. There's only 4 choices. You have 1 through 4 or 0. You have 5 choices then. Did this make sense to you? Okay. Check it out again on the video if you're a little bit lost. Also, with those negatives, make sure you put 1 over that negative power as a positive. Remember, you can do that. Square gives you positive 4. You're adding 4 to both sides. And how to... All right, we're going to start talking about section 11.1. What we're going to talk about in 11.1 are quadratic equations and how to what's called complete the square.
لقد انتشر تسجيل صوتي.
Might not even know what that means yet, but promise you will in just a little while. So quadratic equations and completing the square. Okay, firstly, before we go any further, I gotta kind of tell you what a quadratic equation is. When you hear that word quadratic, quadratic. I know that the quad, it makes it seem like it's 4, but the quadratic equation for us means any equation where the largest power of some variable is 2. So like anything with an x squared in it, if that's the largest power, that's a quadratic equation. Of course, it has to have an equal sign that makes it an equation. But a quadratic equation is a second degree equation. What second degree means is that the largest power is 2. Not 3, not 4, not 5. The largest power is 2. Not 1, but 2. So quadratic means power. This is where you fill in the blank. Quadratic means power 2. Okay, very good. All 4 of you who are with me today. Well, if you really think about it, we've literally been dealing with quadratic equations since the first day of class in here. We've literally been dealing with it since the first day of class because every quadratic equation can be represented as ax squared plus bx plus c equals 0. Have you seen them since the first day of class? Yeah, in fact, that's when we took our break from C.1 to go to C.4 to learn how to factor because that's the only way we were able to deal with those things. Are you with me, folks? So you've been dealing with these by using the diamond method. Sometimes with the extra step if there's an A, factoring them and solving them. Raise your hand if you remember how to do that. If you didn't raise your hand right there, you need to go back and remember how to do that, okay? Go back and look at that. I told you a long time ago, though, that there were some things that you can't factor. Some of these problems you cannot solve by factoring, they don't work. We're going to learn today, and we're going to learn tomorrow and Friday how to do these things without factoring so that we can universally solve any quadratic equation. Would you like to learn how to do that? That way you're not just stuck with factoring. That's cool. Well, we're going to start kind of down here. We're not going to worry about equations with this term right now. We're going to build up to that. First, I want to look at what happens when I take somewhat of a simple example. Let's do x squared equals 9. X squared equals 9. Now, I'm going to show you 2 ways that we can solve this problem. One is the old way, one's going to be a new way. Are you with me? So, old way. The old way you'd solve this is realize, oh, this is x squared. I can get everything to one side and 0 on the other side and then factor. True? How do I get everything to one side here? Okay, so I'd subtract 9, and this would become x squared minus 9 equals 0. True? What's that? Different squares. You all should be just jumping on the spot with different squares, right? So x squared minus 9, you say, oh, right, this would be x plus 3. X minus 3 equals 0. So far, so good. All right. And you go, okay, well, I'm not quite done yet. I would do x plus 3 equals 0. X minus 3 equals 0. Therefore, x would equal negative 3. X would equal positive 3. How many solutions did we get? What was our largest power in our equation? That is not a coincidence. The largest power in your equation dictates how many solutions you're going to get. If that was a power 3, you'd be getting 3 solutions. Power 4, you'd be getting 4 solutions. This is a power 2, you're going to be getting 2 solutions all the time. In our case, that's 3 and negative 3. How many people feel okay with the old way? Okay, that's old. We've done that. Now we're going to look at a different way to look at this. Let's say we kept it x squared equals 9. So in other words, something squared equals a constant. Now using what we learned the last few weeks, probably 3 weeks here, Can you tell me what operation will undo a square? We'll do that. Yeah, we knew that a square root and square, that those are inverse operations, right? They undo each other. We also knew that I could take a square root of both sides of an equation, or I could square both sides, or in other words, I can take both sides of an equation. Do I have an equation here? Both sides of an equation have the same power. Remember that square roots are actually a power. Square roots are a 1/2 power, right? So if I take square root of both sides, that's going to be equivalent. So this says, all right, well, what if I took the square root of both sides of the equation? Look at the board here with me, folks. What happens on this side of the equation? How much do I get? X. That's what I want, right? What's the square root of 9? 3. Wait. Something happened. Did you see what happened? How many solutions did we get over here? How many solutions did we get over here? That's a problem. Why is that a problem? Well, that's a problem because we lost half our solutions. It's like going to the bank and half your money is gone. This is the money, right? We want, even though it's negative, we want the money. We want both those solutions. How do I make this one come out like this one? We're going to talk about that right now. If you think about our original example, x squared equals 9. If you just think about the solutions, you know that 3 is going to work, right? Because 3 squared is 9. You also know that negative 3 is going to work because negative 3, when I square it, what happens to that negative? Are you with me? Negative 3 times negative 3, that negative is gone because when we square something, the operation negative is eliminated because you're multiplying a negative times a negative, that becomes a positive. So when you're doing a square root, when you're doing a square root of both sides of an equation, what's happening here is that you are actually, if you don't factor, you're actually eliminating one of those negative solutions. Because when you square something, you're saying both a positive and a negative at the same number are going to work. Because when I square something, that negative goes away, it becomes positive. Not sure if you're okay with that. So in order to show that, in order to get both of our solutions, what we do down here, this is probably one of the most important things we're going to teach today. You've got to put both a plus and a minus there. If you put both a plus and a minus, that looks like a positive negative in this case. That's saying that I'm going to have two solutions. I'm going to have positive 3, and I'm going to have negative 3. So in our case, when we write it out, we say x equals, yes, positive 3, but x also equals the negative version of that number, negative 3. Now do I have both my solutions like I thought? Yeah. So what are you going to do every time you take a square root? What are you going to put in front of that square root? Notice we don't need it on the left-hand side. Okay, we only need it on one side. We just need it on our constant side. This is already taken care of. X is our variable. So every time you take a square root, you must include plus minus. How do you feel okay with that? Now you might be wondering, well, Mr. Leonard, why didn't we've been taking square roots for like a chapter? Why didn't we do that before? Well, before you actually never did take a square root. It was given to you, wasn't it? It was already on the paper. You didn't put it on the paper. You didn't invent it for your problem. All right, it was already there. It was already done to that point. So if you put a square root on your paper, you must have the plus minus. We're going to write that down. If you take the square root, that means it wasn't there before, and you put it on your paper, you must also have a plus minus right above that. Write that down. If you take the square root, you must have plus minus. What this does, this gives you your two solutions. If you don't have it,